Yeah, go ahead.
Okay, welcome to a new episode of Indigenization Appreciation Hour. And this is, of course, an episode that is taking place in the backdrop of some very important elements, developments, shall we say, especially across the Himalayas. With me, of course, is my associate, Sriram Tyagarajan. And in the next hour, we'll talk about what we should basically do given what is happening across the Himalayas, given what the Indian Air Force could possibly do. So, and what the Indian establishment must do in order to maintain sort of the air power balance, as it were, in the 2030s, even across the Himalayas. So, of course, all of you know what has taken place. The Chinese have allowed two demonstrators to be photographed in and of course videographed in photographed and videographed in broad daylight, but that is their unique way of revealing new developments. They invariably do things in this manner, where there are these teasers that keep coming out with pictures of better and better quality as the days go by. So what we've seen in the past sort of 48 hours or less rather is that the Chinese have unveiled uh, a sort of what the internet may have dubbed as sixth generation fighter prototypes, but they really aren't, as we'll discuss in the course of this program. But of course, they have unveiled very interesting new systems, no doubt, platforms as it were. So one is of course talking about the Chengdu J-36 and the Shenyang JXDX or JXS, whatever you want to call it. Shyam, could you just put those up on the screen for our viewers?
Yep.
So, and so what we have here is we have two aircraft which have obviously been designed for very different roles. Now, the J-36, which was probably revealed first, at least on the internet outside China. Now, that is, of course, as you can see, it's a pretty large aircraft. It's quite. It was in pictures where you had the this is one of the better pictures that have come out. I think earlier today. So as you can see, this is a pretty large aircraft right here, and it has heavy duty landing gear. Yeah, it has tandem landing gear, which you would have seen on something like the BAC TSR-2 way back in the 60s. So, and it's also interestingly, it's got three engines. It's a trijet. Now that is that is definitely a novelty for a for a tactical aircraft. And of course, you have a heavy duty nose landing gear as well. Now, as far as where the cockpit is supposed to be, we can't be uh, you know we can't be totally sure that whatever we are seeing is the cockpit or is the way it really is. It could well be that it's been covered in obscured in such a way that it sort of hides ports in the way you have on, say, the B-21. Anyway, be that as it may, the other interesting features, as you can see on this, it has three engines. It has a very large center line, internal weapons bay, and it has two internal weapons bay on the side as well. So its payload capacity is considerable for a tactical aircraft. And as far as the inlets are concerned, the two the intakes on the side, they are of course carrot intakes, which are the same kind of intakes one would see on the F-22, and those are usually optimized for high speed flight. Mach 1.8 and beyond is also, they're efficient even at those speeds. Now, you, as you can see, there are also towards the in the nose section, towards the as it tapers off towards the nose section, you see both these conformal arrays, as well as you see ports which are covered, which are probably IRST, IRST sort of ports over there. Those are covered right towards the front. So there are some heavy duty sensors also on board this aircraft, and the side looking arrays are suggestive of an air to air role. Besides other things, the sort of the double delta, compound delta shape that you have of the platform. Then the fact that the carrot inlets themselves, all of it suggests that it is capable of flying high and flying high and fast, basically. Of course, there is this the third the middle the centerline engine is probably serviced by a dorsal intake. If you can flip this over around, there's a dorsal intake which is surprisingly, if yeah, this dorsal intake that you see behind what can be called the cockpit, that is of course a DSI intake. And that those are not particular, it's similar to an intake you'll see on some other Chinese aircraft. That's not particularly efficient beyond Mark 2. And again, I'm not an aerodynamics engineer, but I do know a bit about all this. But anyway, so the thing is that is a little, that sort of strikes some people as a little odd, given that there are these carrot intakes, and then there is this sort of DSI intake on the dorsal DSI intake. So anyway, so the point is that this thing has been clearly designed to fly fast, despite this this sort of incongruity of having dorsal and carrot intakes, and it has been designed to carry a massive payload, relatively speaking, and also for endurance. And that is where the probably the three engines come in, which according to Chinese sources are WS-15s, which is of course the probably the best engine they have right now, the best domestic engine. But do remember that it is a fourth generation engine if you go by its specs. Can we have those specs of the WS-15? The intake sizes definitely tally with having a WS-15 on board. I mean, I think the intake diameters are considerable given the overall size of this thing. So anyway, the WS-15, is a basically a fourth generation engine. Now this is of course this is something we've translated from Chinese. This is a sort of slide. As you can see, the fifth generation engine has not even been named yet, and it's currently still is work in progress. They do not have a fifth generation engine at their disposal, and so you can't really have a sixth generation fighter with fourth generation engines, even if you put three of them in a cleverly designed plan form. See, and also I'll tell you one thing: the if you see the reason why I'm bringing all this up is because there are a lot of people who've gone around saying, "Oh, they're 50 years ahead. Let's say they're light years ahead now of us." They are not. They're not light years ahead. They have a considerable more amount of money to spend. They are much more dedicated. They are much more conscientious, and they are persistent. Okay, and they have gone step by step by step. Right, this the J-36 that you see builds on the J-20 before it. It builds on the J-20. If you see the J-36, the stealth features of the J-36, you can definitely see some of the J-20 lineage in it, and that's not surprising because Chengdu Aviation Company, which is a part of Avic, obviously, is the creator of this design. So we should not be surprised. The J-20 elements are definitely there in the plan form. Then if you look at some of the other elements as well, right, the platform alignments, as I said. Then of course you also have those canted plane surfaces. Those are all similar to the J-20. But I can say one thing, that given that this is a tailless design and therefore has all aspects stealth, they brought all aspects stealth. They packaged all aspects stealth into something which is high endurance and is capable of high speed as well. So without belaboring the point, here what we see with the J-36 is that it should be capable of super cruise, not at anything like Mach 1.8 obviously, but at super cruise over considerable distances while carrying a considerable payload, which could be comprised by both air to ground munitions as well as air to air munitions. Air to ground, you can have the KF-98A, you can have some of the new air launch ballistic missiles as well. Yeah, there's this debate over whether YJ-21 will fit in or not, but they have stuff other than the YJ-21 as well in the works. So They've had it for a while, which may be able to fit in the center line internal weapons bay. And the other aspect is this could well be loaded out with a whole bunch of PL-17s, and it would take off from something from one of those airfields in the Tarim Basin. So in a sense, from our while the Western commentariat is of course focused on the Pacific fight, from the Indian perspective, this thing is problematic if it actually completes development and ends up being produced like the J-20 and is even reasonably meets its design goals. It is problematic for us because one of the big advantages we have is of course the fact that the PLAF, most of the PLAF airfields are on the Tibetan plateau, with concomitant penalties as far as payload and endurance are concerned for fighter jets taking off from there. They have a lot of airfields in the Tarim Basin also, but those are located further away from most of the line of actual control, except of course Eastern Ladakh. So, but even then, those are not really mutually supporting bases in the way in which China would like. But something like this would obviate that problem. Something like this with a much greater endurance than a J-20 and a very sizable payload will mean that they will be able to, not fully obviate, but make up for that, for the lack of mutually supporting air bases. This will be able to hang around high and in cold mode and basically receive targeting data from off-board sensors, maybe other UAVs that are operating in front of it. So it'll have that, maybe it'll have those sixth generation features given its size. It'll also have some pretty heavy duty electronic warfare capability, and those three engines will help with that. But because they do not have even a fifth generation engine, they need those three engines, right? They need those three engines. They need three engines for Super Cruise, and they need those engines probably for takeoff as well, and definitely from some airfield. So Shyam, why don't you take us through the kind of capability gap that the J-36 might be able to address if it completes development and is successful?
Yeah. Okay. See, right now on the map that we can see, the position inside India, right at the border with the Chinese, is DBO, Daulat Beg Goldie, and the airfield on the other side. One second. Yeah. So, sorry. As you can see, there's a big valley right here. So that's the Tarim Basin, and these are the Tian Shan Mountains. If you've read Huansang and Fayan accounts, they circled this, came to India through Tajikistan and current day Afghanistan. Right. Anyway, history lesson aside, Baingolin. I tweeted about this earlier today. So Baingolin is here. Turpan and Korla, all of their bases, and including the big runway that they have and a space launch facility, as well as their new giant ICBM fields. They're all based in that area, right, north of Tarim Basin. So as you can see, it's about 1,000 kilometers from our border. Add another 500 kilometers all the way to Delhi. Might as well. Right. So, yeah, Delhi is 1,655 kilometers, give or take. So as you can see, this is not bad. And remember, the Su-30 MKIs from the Indian Air Force did this all the way from Tanjore, which is here somewhere, to Nicobar to test the air launch BrahMos. They did this distance, 1,700 odd kilometers, up and down with 2 aerial refueling on the way to the target and once on the way back. So if the Su-30 MKI, which is arguably a heavy fighter, can do this, imagine something that is... one sec. Let me just put this up. If you look at this, that thing is huge. And it's got this double delta type planform also. So the wing skin maybe not as big, as much volume as a flying delta to carry as much internal fuel. But I'm still sure the J-20 is huge, we know. So if this thing is bigger, or even, say 1.5 times or 1.3 times the J-20 size, it can still carry sizable payload given the size of the internal weapons bay, as well as extra fuel to carry it. So 1,000 kilometers up, and it doesn't even need to go back to Bangolin. And if you look at Google Maps today, you can see J-20 is based there, and obviously all the other bases closer to us. But see, this is something that can be done, and I'm pretty sure the Chinese are not idiots who have who build platforms for each theater separately. So this thing probably can do the first few island chains on the Pacific side also. Invariably, whenever they develop something, it always goes to the east first and then gets populated everywhere, right? All of the bases. The J-20 happened like that. The J-10s happened like that. I'm pretty sure this will also be similar. Not just this, the other stealth platform that they showed today. So big internal volume for fuel, most likely, and we can see the huge internal weapons bay. So 1,000 kilometer radius, at least one way distance, should be very doable for them. And given possible locations for them to be based, we'll have to look at how we can detect them, keep an eye on them, and see when they muster and everything. Because all of those bases, remember, not just the lower Tibetan air bases, all of them have aprons covered, facilities for helicopters, fighters, and I'm pretty sure something this big will maybe need newer facilities. It'll get built very quickly. It's not like us, right? So I'm pretty sure it'll get built quickly. So threat wise, I mean, it depends again. The volume that they can build, when we will see them get inducted, when they'll eventually get to the Western command, theater, might take 10 years. If this is a prototype 1 or a prototype 2 that we're seeing today, I mean, if they're willing to get it photographed in daylight and showed to the world, I'm pretty sure it's undergone a few flights already. So
yeah, about
like I
that,
said, it'll take a few years.
So Shriram, if you see the bot number also J36011, it is suggestive of this being a much more advanced iteration than just an early demonstrator.
First one, yeah.
Yeah, and that is the way the Chinese operate anyway. That is what we saw with the J-20 as well. Circling back to your earlier point about the double delta wing being able to carry a lot of fuel, so the fuel fraction on this thing will be considerable. Clean fuel fraction will not be anything less than 0.35 or more, maybe more, probably 0.4.
Maybe more,
yeah. So this thing will have considerable endurance. It has more endurance. And with those 3 engines, it has more endurance. It has better super cruise capability. It makes up for the fact that the Chinese make up for the fact that that AECC, their Aero Engine Corporation, has not yet produced a credible 5th generation engine by having this 3 trijet scheme, right? With the WS-15s, which is currently their best engine. But as I said, the WS-15 is very much a 4th generation engine in terms of its overall pressure ratio.
Specs the greater and technology, yeah.
Exactly. If you look at the overall pressure ratio of a WS-15, it's very much 4th generation technology. It's less than 30, right? Or at best 30 can be claimed. For those who want to understand this, higher the overall pressure ratio, right, the better your specific fuel consumption. Right, you're greater. You can achieve a higher efficiency. Basically, of course, there are issues because the temperature at which the last compressor stage operates becomes considerably higher as you keep increasing the design OPR of an engine. So you need better materials even for the compressor stage. We'll talk about this in subsequent IH episodes. So now,
just to give a quick idea about what. One sec. Yeah. About what engine generations are, right? So this is something that was shared by GTRE.
Yeah.
Sorry. As you can see, 5th generation is the F135, has an overall pressure ratio of 30 to 35, which is the amount of compression that the engine does before adding fuel. So the EJ200, F414 all have lesser pressure ratio, somewhere in the 20s. And then the 6th generation is obviously something the Americans are working on. And that's not up for us. So even for the AMCA, we're looking at getting close to the 5th generation technology. I mean, the specs. Single crystal blades of a higher generation. Maybe thrust vectoring later on. pressure ratio of 4.5 for the fan and OPR of 30. So
No, for the
that's our target.
for the proposed fifth generation engine definitely meets all of these specs that we can see here, right?
Yeah,
FPR of
that's
greater than
that's the aim
4.5. Yeah.
for the
And
AMCA.
yeah, and turbine material you can do it even with second generation for the for the blades, for the HPTV blades or the LPTV blades. You can do it with second generation supercritical alloys like CMS X4, X4. That is good enough for that.
Yeah,
Or
I mean the Kaveri does it with DS blades. So
Kaveri has DS blades only in the high pressure turbine section, and it has equiaxed in the low pressure turbine section.
correct. So you can imagine
So
there is a
yeah,
generation behind in terms of blade
yeah,
material technology, and it
yeah.
still
So
meets the 404.
yeah, Kaveri high pressure turbine blades are all CM2 247 LC, which by the way Midhani can also make. It's out of patent and Midhani can make it. So anyway,
Ah,
but this is a very interesting point, and the most important part is that you must have the turbine blade material for sixth generation. What is a sixth generation engine? The kind that really matters. See, a sixth generation engine is an adaptive cycle engine, okay, and the type of adaptive cycle engine that matters really, or a variable cycle engine, is what is called a three stream engine. So the turbofans that we fly today, fourth generation and all, they are all two streams, right? So there is because of the bypass, low bypass. So there is a cold stream that is goes from the fan to the outside, and then there is of course the stream that goes through the core of the engine, the hot section. So those are the two streams. In the case of a three stream engine, you would be able to direct the third stream either in as part of the cold stream or through the hot section of the turbine, depending on your requirement. When you want loiter, you will do the former. When you want performance, you will do the latter, right? So
yeah.
China is nowhere.
In
Yeah.
a layman's terms, you could say this adaptive bypass, right? You can change the
Yeah.
bypass ratio on the fly.
Yeah, 1 second. You did the converse, Shriram. What I said was the layman's way of saying it. What you said
Sorry.
was the technical way of saying it. Anyway, so we are very far away from a stage where even the Americans have basically mastered the variable cycle engine technology, and they are the world leaders, by the way. If you want to know where things stand, it's the Americans are here, the French after them, the British, they are falling out of the reckoning pretty much every other day. The Russians can meet the design specs, but they can never meet the the basically the parts life
MTBO,
specs. Yeah,
yeah,
yeah, MTBO,
MTBO,
those things.
lifetime
And
spec.
yeah, and MTBF also of critical parts, so you can
Yeah,
have critical engine failure at any time. And the Chinese are still over here, despite all the help they got from the British over the years. By the way, just for our viewers, I'll let you know, I have in the recent past, I have even met people who at one point used to work for Rolls Royce, who are Britishers, of course, and who were in China for several years, by the way, helping out what is called AECC now, Aero Engine Corporation of China, and mostly on the investment casting front, which you have to master for rotors and stators, basically blades and high pressure turbine blades, low pressure turbine blades, high pressure turbine vanes, low pressure turbine nozzle guide vanes, basically NGVs, nozzle guide vanes, and turbine blades. So that is of course, but we do have, as I had said in the earlier program as well, we do have interested companies working on these aspects over here, and they are not bad at all. So that brings us to this point, that what should our response be to what the Chinese have unveiled? Of course, they've unveiled another prototype. Let us show that side by side, Sriram, if you
yeah.
would please.
Yeah, you go
They,
ahead. I'll put it up.
yeah. So they have not just unveiled this J-36. They have also unveiled something that has been developed by, or is being developed by Shenyang Corporation, the eternal rival of Chengdu. But these are both are of course part of AVIC, the aviation, the umbrella corporation, state-owned umbrella corporation that has sort of subsumed all of these older companies now. So what you see on that front is that you have something which is of a very different design than what you see in the case of the J-36. So this notion that there is some kind of a fly-off between these two designs, as was initially being speculated, is, I think, not on the money. It is far more likely, as many Chinese sources on Weibo and other places are saying, that these are all part of a new family of large aircraft, large combat aircraft, which includes the so-called H-20 bomber as well from Xi'an, right? So which might be the so-called teapot to these teacups, and all of them can fly in a networked environment, and they will obviously operate with other sensors as well, flying sensors, ISR UAVs in particular, and they will all be able to act as motherships for close combat aircraft and other sort of for manned unmanned teaming purposes as well. Whether these prototypes are optionally manned or not, we can't say for sure at this moment. That is, of course, a sixth generation feature, what is generally considered a sixth generation feature. They do not have sixth generation engines. They are not capable of the kind of being efficient in all kinds of regimes. They are not. That's another sixth generation feature. Whether those ports, those large EOIR ports, whether they can also serve as sort of mirrors for may also have a directed energy weapon sort of house behind them. That we'll have to see. With three engines, you might be able to do something on that front. You can definitely power heavy duty EW. In the case of the Shenyang demonstrator, of course, I don't think the kind of EOTS that is hanging beneath the below the nose is going to house any kind of directed energy weapon or anything. I think that is for sensing purposes only. So the I still can't see that Shenyang demonstrator picture.
Yeah, I'm not able to put it up, but yeah.
Okay,
go ahead.
let me try putting it up
Yeah,
from my
please.
end then, right? So just a second. Just bear with me for a second.
Yeah,
The reason
while Saurav does
yeah,
that,
yeah,
let me just
go ahead.
answer a couple of questions.
Answer them.
This is the spaceship in some God knows some other galaxy. I'm trying to get away from Indian defense procurement. Yeah, so Hitesh, not to mention it feels more of a long-range bomber than a fighter. You could call it a fighter bomber, right? It clearly has a long range. I mean, guessing from the size of the airframe itself and the payload. So it could be used for targeting enemy bigger platforms like AWACS and refuelers with long-range missiles, or for strategic. Okay. Sorry.
No, you answer the question first.
So long-range strategic targets, time-sensitive targets, buried targets which need aeroballistic missiles, those might need it, as well as let's say enemy AWACS and refuelers. Those might need long-range, heavy air-to-air missiles. And being VLO, obviously, the closer you can get to the enemy AWACS or ELINT aircraft, I-stars, all of those require something that can get in quickly, have long range, be less observable, and prosecute the target and come back. So it could be a long range fighter also. I'm pretty sure. Okay, let's not call it pretty sure, but the option exists to have LPI radars, L-band on the wing leading tips. There are cheek arrays, probably got an EOTS, maybe not now, maybe something somewhere in the future. Yeah, I mean, I'm pretty sure it can do both. Primarily strike oriented, maybe, but secondary air-to-air role definitely should be possible.
Yeah, but the larger point is that it sort of allows them to eschew their weaknesses. The weakness that they have being based on the Tibetan plateau. So here we have the two side by side. On my left, or rather, let me say on the left of the screen is of course the Chengdu J-36, which we've talked about, and this is the other one that was unveiled, which is the Shenyang JXDS or JXX, as some people are calling. Now this of course has that cranked arrow or lambda wing kind of planform. And interestingly, it has this, this tail fin. It has this adaptable tail fin, so which in vertical position can be used for maneuverability. Usually, again, I'm not a great aerodynamics expert or anything. Let me be clear. And of course, you can use it for high-speed flight in the horizontal position. And I would venture that even the wingtips are, foldable. So This thing is more of a fighter than not. This thing is probably more of a fighter than not. Again, I don't think it has sixth generation engines, so this is not a next generation air dominance kind of equivalent or anything, but it is supposed to probably work in concert with this and the H-20, right? In a sort of network scheme to ensure local air superiority at the very least. That must be the agenda behind all this. So now, having seen this, and of course we'll soon see the H-20 as well, which the Americans don't think highly of, but anyway. So what I can say is that the answer to all of this cannot be some knee jerk import, right? If that is what some people are proposing, that will not solve our problems at all. See, I'll say something. The Air Force was obviously not as that bothered by the J-20, even the J-20S, that they would that made them, change their plans for the MRFA, or made them, sort of not agree to the current timelines for the Tejas Mark II or the AMCA for that matter. So the Air Force wasn't that concerned by the J-20S, is what I would say. Okay, they were concerned. Anybody would be concerned even by that, but not overly concerned. Now, if you have these things, even though they don't have sixth generation engines or anything, what the Chinese are very cleverly doing is they are proving out their flight control system for very advanced planforms, tailless designs on such huge aircraft. They're proving that, and they're going to prove that more with, of course, the H-20 as well. But they're proving it out. They're going to refine that, and they're going to be future ready when they have better engines. And those engines, and I'm sure the margins are there for better engines to be put on these basic planforms, these basic designs. So they're not basic designs, they're very advanced designs actually. But what I'm saying is that these advanced designs are being tested and refined even as we speak, and being made and are being kept future ready. Now that is the kind of thing you can do if you have your own aerospace design practice. That is not the kind of thing that you can do if you are constantly looking towards the global market for a quick fix solution, which just doesn't exist in this case. Because if by the 2030s these things mature, then something like the F-35A is pointless anyway. In any case, as you all of you know my views on things like the F-35, and looking towards the Americans for the tip of the spear, as it were. And F-35, as I said the last time, end user monitoring agreement the end user monitoring agreement that will come with the F-35A will be the least of our concerns as far as that platform is concerned. And by the way, there is no point in looking at the marginal cost in Government Accountability Office reports from America and say, oh, the F-35 is now at 89 million or so. That is not the price at which you will get an F-35 from America, an F-35A. You've seen, just to buy 31 MQ-9Bs, how much you've had to shell out, over 1,000 crores a piece, when you add on all other aspects that come as part of that package deal. So looking at the marginal cost of the F-35 in some batch production in the United States does not at all give you an indication of how much the total acquisition cost of the F-35A will be, what the life cycle cost will be, what are the constraints you will face while operating the F-35, what are the huge challenges you will face in terms of Trojans that will come with the F-35A, despite the Americans being India's supposedly natural partner, which of course it isn't. Then that's a story for another day. And not to mention the biggest problem of them all, the whole thing will be at the mercy of the Americans, the whole platform. And you've already seen what is happening with the F404 engine for the F404 IN-20 for the HAL Tejas Mark 1A and Mark 1 and Mark 1A. So Ajay, about that, let me just, as an aside, let me just tell you, till date, if you go by GE's website, India has basically been able to procure 75 F404 IN-20s, right? And so you can imagine why HAL is not being able to deliver any new Tejas Mark 1A just like that. Because the number of Tejas that have been built over the years, which have used not just the F2J3 but the IN-20 also, is considerable. It's, there's several, or you have 40 right there. I mean, not all of the 40 have still been delivered, but at least 40 are consumed by the Mark 1 production lot itself. Then there are the demonstrators that came before that, then some, and the LSPs as well. So you have very few engines actually lying around, because as you know, any even of when you talk about a fourth generation engine, any plane, any single engine plane using fourth generation engines will use at least 3 to 3.5, 3 actually up to 3.5 of them in the course of its operating life cycle. So what you're basically seeing now is that the first Mark 1 A's will be delivered by HAL with engines that were used for development and older orders, to service older orders, which is why they are being called Category B engines and all that. So anyway,
And
so yeah,
to
yeah,
add
go
to
ahead, go
it,
ahead, go ahead.
see
Yeah,
the F-35 is pretty much a black box, right? So even
yeah,
the Brits, who are supposedly founding contributors to the F-35 program,
yeah,
are finding it difficult to make changes on their own, get access to a lot of data because it has to go back to the US and then they have to ask the Americans for it. There were quite a few articles recently saying, despite us being, joint founding partners and put in so much money, uh, just to get access to our own data from our own fighters, we are having to go back to the Americans. And everything is a black box. You can't touch this, you can't touch that, all of that. Now, if that is the case for the Brits, who are like pally pally with the Americans, imagine the case for us. Another thing is the IAF, rightly so, prides itself on doing the Darren upgrades and keeping a lot of fighters flying, including the MiG 21s. Yes, I mean, they've done a great job keeping their aircraft flying despite the lack of induction. And remember, when it gets old, spares become a problem. The Indian Air Force is hawking M53 engine parts in Aero India and Defense Expo, saying, somebody please make these parts for us. Now, if it's an imported aircraft
that is a
and it's a
Mirage
generation
2000
minus one,
engine.
right? Yeah, Mirage 2000 engine, right? So
Yeah.
if you have a generation minus one platform and the OEM country has moved on, then their entire supply chain has moved on to the next product. So getting spares for your previous generation engine that you're sticking on to for whatever reason is now a major headache. So which is why there was so many searches and reaching out to countries which have used the Mirage 2000 and have now moved on to the Rafale, because we are desperate for a lot of key parts that are no longer in production, because all the French OEM suppliers have now moved on to the M88. And if we buy the Rafale today and the French start giving away a lot of their Rafales to Chota Mota countries, Algeria, Morocco, whoever, in 20 years' time, if you still hold on to the Rafale and they've moved on to the FCAS, remember the French are single country and they most likely cannot afford two platforms at the same time. The Rafale Marine and the Superintendent is a different issue. But today they do not have Mirages. They've given off. They're selling used Rafales from Adla to Greece and a few other countries because they can't afford brand new planes. Indonesia too, I think, recently. So coming back to the point, right? So if you buy the F-35 today, you will be faced with a similar issue 15, 20 years down the line. Oh no, we have an operational necessity. Yes, the operational necessity issue came about because of our lethargy. Another day.
Yeah. So the thing is, as you clearly pointed out, so and the worst part is that because the number of the sheer volume of parts and components that you want for the M53 pool that you have is not very high, you get these very lackluster responses to EOIs anyway, even from companies that may have the capability to give you what you want. So you mentioned the FCAS. Now, whether it be the FCAS or whether it be GCAP, FCAS is of course the French program to develop a new sixth generation fighter.
GCAP is the Tempest program.
GCAP is of course the UK led program. None of them make sense for India at all. Okay. If the PAC FA, if the FGFA program with Russia, where India was an actual equal partner, did not make sense at the end of the day, you can forget about these programs making a sense, where others will be leading project definition requirements. Okay, and in any case, these things are not likely to see light of day so easily. because of the fiscal constraints that all of these countries face. We'll go into, maybe I don't want to waste a lot of time on this, but suffice it to say, neither will you get what you want, neither will they be particularly successful. So, but the thing is that, as you rightly pointed out, France always wants to play in the big league, but no longer has an economy, or actually, some people claim it never had an economy to rub shoulders with America in places where it counts. France has a nuclear powered aircraft carrier. Of course, it just has one, and it's going to, and then through the Pang program, it's going to get another. But it has both it has a 4.5 generation land based fighter, and of course a marinized version of that fighter as well. And it has in the Mega Joule facility, it has a laser inertial fusion facility, which is the equivalent to the national ignition facility of America. So it has always tried to keep pace, but it cannot keep pace forever with the kind of economy it has. Importantly, it doesn't have an engine beyond the M88 at the moment, right? The M88 is a fourth generation engine. If you look at the kind of performance it delivers with even a mass flow of 65 kg per second, that's considerable. So in fact, coming to what we should do is, we should definitely explore engine collaboration with the French. We are in talks with the British and the Americans also. Let's see if F414 comes through, but it will not provide a baseline for future developments, unlike what people think. We may explore that in another subsequent program. But suffice it to say, what you're getting as part of the so-called 80% TOT is nothing that is going to make you ready to produce a fifth generation engine, really. In fact, many of those things already exist over here, distributed amongst various companies, not under a single engine house or anything. Anyway, that's a different matter.
Yeah.
And you have the British. The British are, of course, collaborating with DRDO on specific engine-related issues. There's no point in going into the details of that. So they are not ruled out a priori. But remember one thing: except we don't have anywhere near the level of trust with the British that we have with the French or the Russians, right? And given that the British are very much part of the Five Eyes, I don't think they are front runners for something like this at all. So the bottom line is, if we need to collaborate with anybody, we should collaborate only on the engine front, not on the platform overall system or platform front. We should collaborate on the main subsystem front, which is the engine, which is the Achilles heel of India, basically. And there can be no real Swadeshi, there can be no real independence without having your own propulsive capability across the board. And I'm not just talking about aero engines, although that is the so-called pinnacle of manufacturing, but having your own diesel engines for prime movers for ground-based systems, having gas turbines for ships as well. Of course, if you crack aero engines, you'll get those gas turbines for marine gas turbines as well. So the one thing that we need to do is, this is the time when we need to embark on the development of a fifth generation engine. And if it turns out that even the French are not really willing to give us what we want at all, and are asking some unobtainium price, do it yourself. That is the way to go. We have the capabilities. Do you know, I don't know whether our viewers remember this or not. In 2006, while we know about the Safran audit that was done on the Kaveri in 2017, which said that yes, you can create flight-worthy prototypes on this baseline, there was, in 2006, GE also did some reviews of the Kaveri baseline, and they were actually impressed with the kind of fourth generation engine India had come up with. 2005-6, it was reported in the press also, right? So India has always had the talent. As we speak, there are people from GTRE who have worked on the Kaveri who are being absorbed by General Electric, as Sriram would tell you. So this is the sort of thing. It's a question of backing ourselves, and if we do go ahead and fly the baseline Kaveri on a Tejas test vehicle, that itself will not just give us very valuable data. Why do we really need a foreign collaborator? Do we need them for specific technologies, specific manufacturing processes? We need them most of all for data, for testing data that we don't have, because we never created the test facilities ourselves. We don't have a flying test bed. We don't have a high altitude engine test facility. We don't even have turbine test facilities that can, cater to mass flows beyond 90 kg per second. We don't even have that, right? So all of those have to be built. I have made some estimates over the years. You can have a high altitude test facility. You can have a twin turbine test facility for 130 kg per second mass flow. You can have even an isothermal forge that you need for, near net shape production of bliss, or even low pressure turbine discs. This is what you attach basically the blades to. Okay, when you talk about a low pressure turbine disc in an engine, that is what the blades, the sort of turbine blades, will be attached to. For that, you need an isothermal forging plant. All of that can be done for as much as 30,000 crores, and you are spending 4 times that amount on expressways nowadays. Some expressway from X to Y destination, you spend 4 times that amount. This will give us returns in several multiples of that 30,000 crores, several multiples. And once you have engines, once you have an engine, the propulsion, once you have the heart of the matter at your disposal, you can design all kinds of shapes. The fact of the matter is the Chinese are being able to do all this because they actually have flying fourth generation engines which are in production, like the WS10C and the WS15. They do have that. So that is so this is the kind of scheme. This is the sort of disc. These are the
The disc is the bit in the middle. It's I mean, as the name suggests, it's just a circular disc of titanium or nickel alloy, and the blades are attached to it.
And of course the cost I gave, the estimate I gave is only for those facilities that I talked about. Production facilities and the production of a certain number of engines will cost more, obviously, maybe 80% of that for a certain number of engines. But the point is that it will be money really well spent. This should be our and see, it's like this. The thing which can take on the kind of architecture that the Chinese are coming up with in the form of this J-36 and JXDS and those ISR UAVs and the space-based segment requires an indigenous response in the form of the AMCA, in the form of a networked LCA Mark II, in the form of our own ISR UAVs, low observable UAVs, in the form of our own space-based segment. All of this will cost a lot of money, and of course, at the heart of it will be the 5th generation engine, which will give us a performance.
Strike aircraft, low observable strike aircraft.
So let us come to the second part where we talk about the UCAV section. Why don't you take us through that, Sriram? So
so now we have the SWIFT program, right? And that is the only sanctioned program right now. And that is a technology demonstrator using a smaller engine, which is essentially a cruise missile engine. Now, the Ghatak, at least as far as what ADA told us, was somewhere in the LCA class. I mean, going to be designed in the LCA class, single engine, powered by the KDE.
Just sorry to interrupt you, but it may not be called Ghatak anymore. Okay, so let us.
Nomenclature is irrelevant right now, but Ghatak is what everybody seems to go by. But let's just call it the UCAV for now, flying wing UCAV, right? Full scale. Now, given the kind of competition that we have, and remember, it's not just the land war, right? Everybody keeps saying the same thing. Everybody forgets the seas and the Indian Ocean region. We're too land focused, and the contrarian, the opinion is that no, our entire focus is the IOR. We have, we've embarked on a massive shipbuilding spree. Lots of OPVs, NGOPVs, and frigates, and we just had a P-15 Bravo and a frigate being delivered on the same day last week. So that is fine. And we've started on a 2 SSN program. We have this ballistic missile program, ballistic missile submarine program in the Arihant and follow-on classes and all. But see, again, the need for smart as well as LRAS SHM is because we do not have the capability to air deliver something against the surface group in the IOR, because that will need long legs. We had the Tupolev Bears, which were used in maritime patrol role. It is unfortunate that a service which is using something that could also function as an intercontinental bomber but never had a follow-on aircraft that could do that role. Imagine you had something like that. And the Air Force had the MiG-25s, right? To follow on, we never had anything of that sort. I mean, we supposedly switched to the satellite capability, but again, sore point again, we do not have the kind of capability that we should have. So to hit something deep in IOR, any PLAN surface fleet, our only option right now is the ballistic missile first stage launched smart or the ALSM, ALSHM. Those are fine, but again, air launched means you can get quicker response, you can do roving patrols, a lot of flexibility that land based missile does not give you. And remember, it will be expensive. These things use the first stage out of SRBMs and IRBMs. Those do not come cheap. You cannot build an entire rocket force for hitting targets across the IOR using those. And you have to distribute them East Coast, West Coast, all the way down IOR. And the other thing is, it is a very, very busy shipping route. And there are multiple global airline pathways, right? Highways, let's call it. So you have all of these complications. You can't just lob ballistic missile. I mean, yes, when it comes to a war, civilian aircraft and shipping will find another way. But still, who says it'll be a proper war where everything will be announced beforehand? That might not happen. And see, again, do we where's the Navy in the whole UCAF program? They're the ones who should be, pounding the door at MOD saying we need something big, something that can carry a large payload, can loiter for hours together. 8 hours, 10 hours endurance is a minimum, because like I said, you take a civilian flight from Madras to Port Blair, it takes 2 hours.
Yeah.
So imagine having to be on station at that distance for 6 hours. So 2 hours to go, 6 hours on station, 2 hours back. That's 10 hours easy. So you need something big that can carry a lot of fuel, a lot of payload. Imagine the Chinese are showing us what you can do when you have suboptimal components to play with, right? Nobody's really built anything with 3 engines significantly, right? They've had proper engines, they've put 4 in the B2, and it worked beautifully. Nobody says, let's just put one more engine in the middle. They found a way. So we also have to find a way. Doesn't matter if it looks ugly, right? Doesn't matter what color the cat is, as long as it catches mice.
Lockheed Martin TriStar was the tri-jet you had.
I mean, you can use the McDonnell Douglas MD-80
yeah,
with the engine in the tail fin.
But one thing is there, what you pointed out is important. While the Su-30 MKI equipped with a BrahMos gives us a certain capability, and the Rafale with the Storm Shadow, the kind of persistent capability that you outlined requires new airframes, new platforms. And so that UCAV, that flying wing UCAV, that has to be progressed with the Kaveri derivative engine. Kaveri derivative engine may be ready or being close to ready. I'm sure it will do well in the higher, on the flying test bed also in Russia, where it might be headed. But the platform has to be ready as well. Right now, we only have the Swift. The larger platform, which will be a certain number of tons, much heavier, which will be equipped with the KDE, needs to be sanctioned. And because once we prove, because that will be our entry into the tailless space, the real entry into, a space where there are no vertical stabilizers, etc. So, etc. And that can provide the basis for a 4-engine flying wing design in the future, which can serve some of these persistent be used for some of these persistence demanding roles that you just outlined. So that is the other thing that we need to now hasten, that the Indian Air Force needs to now really push. It needs to be pushed big time, and the Navy needs to push it. In fact, the Navy probably needs to push that more than the TED-BF, like you said. So we already have 2 things that the Indian establishment should definitely do. One is get serious, make the 5th generation engine effort a budget item. I look forward to seeing the finance minister announce it during her budget speech. Anyway, that's something I am saying. Okay, and push the UKF development project with the KDE. And the third thing that has to be done, given the capriciousness that America is showing, is that we need to now embark on a Kaveri 2. Okay, a Kaveri 2. The old Kaveri design has seen its problems being fixed, especially on the flutter side, the afterburner screech side. In the next episode we'll go into details of that. But these have all been fixed as far as the old, even the baseline Kaveri is concerned. Casing treatment was one of the main tools, or rather one of the main approaches used to fix the flutter problem, apart from redesign, of course, of blades and all. And of course, then you had the compressor problems, where compressor stall issues were also rectified. You had modifications to the root attachments, so on and so forth. Anyway, I had said I'll write an article on it. I'll go into the details. So the thing is that with a better core and the kind of high IDCL fans that are available to India now, and the fact that afterburner issues have also been solved, we can come up with a 98 kilonewton engine in this decade, which will maybe not have the same parts life as the F4104, but will be a good contingency plan, and we need to embark on that now. That is what
will be our own.
Yeah, it'll be absolutely our own, and it will make sure that even the first 40 or odd AMCAs can be powered by that. The AMCA will not be able to super cruise
people remember, sorry to interrupt, but if people remember, there was the very specific taunt, what 7-8 years, until 7-8 years, maybe even 5 years ago, that the two main parts of the LCA, which is the nose, the radar, and the tail, the engine, are both imported. So what good is your indigenous fighter? Now the nose is ready. It's only the tail that needs to get ready. And GTR is confident that they can do it in 5 years, provided they get the support. And compared to the baseline Kaveri, we've progressed in a lot of places, be it aerodynamics, be it materials, compute, all of those areas. So we should be able to get an F414 equivalent into the LCA within 10 years, including certification. We should. Whether we are able to do it or not, leave that question aside. We should. Because, like Saurav said earlier, a fighter will use multiple sets of engines throughout its life. Right now, brand new, the LCA uses the F404. But in 10-15 years, when it needs new engines, we should have our own engines that the LCA can use. It's not that once you buy the GE engines and that's it. Right? In 10-15 years, we will need engines. Like take the Su-30 MKI, for example. The MOD just signed a deal with HAL for brand new engines, right? So that is how the fighters go through engines, and we should have our own, at least, if not on the first run, at least the next one. And given that we're going to buy another 97 of the Mark 1As, we should definitely have our own engines. And couple of quick questions.
Let's go to questions.
Nitesh and user X A101, thank you so much for your contribution. We run entirely on contributions and of our wonderful viewers as well as our own. So we're very grateful for any contribution that you make. So thank you again. Nitesh's question was, in our theatre of operations, where would MKI with Virupaksha GAN ASA and the Astra Mark II stand a chance? I would say, from what I've heard with talking to people, is that the ASA on the MKI will be like a mini AWACS. That thing can see far. And you have to realize that a lot of our specs, when they're put out, you have to give them a certain factor, different multiply, and guesstimate the actual performance. So, this is true when it comes to missiles. This is true when it comes to radars also. And when you put them both together, you can imagine, right? And even for the Chinese PL-15 missiles, they have put up signboards with their true range claims. So ours will be definitely on par, and after that, it's up to the users, right?
Yeah.
You have tactics, uh, strategy, all of that. So that is up to the user. That is where the IF has done remarkably well over the decades. I'm sure they'll find the best way to optimally utilize whatever these guys give them. And
So
as far as capability goes, I've heard it's excellent.
so that
And
brings us to
remember,
the
the
yeah. Sorry.
baseline Uttam is as good as the RB2 on the Rafale, right? Um, SWAT, give or take a few. But as far as pure performance goes, it's on par with the RB2.
Yeah, and
And
especially the RB2E that will be and is better than that actually. Ah,
on
so
the Rafale that the Indian Air Force
yeah,
uses.
yeah. So
And
that's the fourth point, right?
yeah,
Yeah,
and
go
one
ahead.
more
What were
question.
you saying? Yeah,
One more
yeah.
question.
No, I'll just add to what you said.
Ha,
One
yeah, go
thing.
ahead.
The fourth thing that the Indian Air Force obviously needs to do is induct indigenous munitions in bulk, not 100 here and 200 there, but really tank up for a major war. Because the one thing that can help, also mitigate some of the disadvantages that you might face in the future is long ranged indigenous munitions. Okay, India, thanks to the integrated guided missile development program and the continuity of the program and the programs that branched out of it, India is a missile power, right, and the munitions power also, and that is what you need to really leverage while you try to catch up with China on on the aviation front. So in the years ahead, India has to bank on its existing strengths and take them to their logical conclusion to even things out, even as even as it works on a symmetric response. It cannot be just a purely symmetric response, right? Anyway, let's go to the next question.
Yeah, sir, when can we expect Onera like facilities?
If it is sanctioned within 2 years.
It can be done quickly, like Saurav says. The question is, I would say we need, our defense R&D budget is about 5% of the entire defense budget. And the defense budget itself is the single largest spending that GOI does. So there is not a lot of leeway to increase the defense budget. So there has to be some creative way of finding money to fund all of these high budget infrastructure needs that we have. Unless the finance minister finds some way to do it, it will be very difficult to do it within the R&D budget. There has to be some initiative, some vision from the Prime Minister's office and the finance ministry, because without financial support, this will not happen, because every single facility is hundreds of crores of rupees. And every year we delay, the cost goes up. And remember, a lot of these facilities can be set up using predominantly Indian companies with some help from abroad, from facilities which have already set up in Europe or US, anywhere, even the Russians, for example. Our wind tunnels, the hypersonic wind tunnels, have been set up by companies like L&T and Tata, with obviously foreign help.
Yeah, but that foreign help is forthcoming, so it's not going to be a problem.
Yeah.
The
If
money
they
also
realize that you're going to do it on your own anyway, even if you have to struggle for a couple of years extra, then they will come forward and take the money.
you will not have to struggle. These things are available now for the right amount, right? To India they most certainly are, except of course certain things from America. Those will never be available, but that's a different matter. The fifth thing that the Indian Air Force must do, and this is something that is obvious to everybody, is create an integrated air and missile defense architecture that is relevant to the kind of threats we are going to face, which means great induction of better indigenous counter stealth radars, low band radars, VHF radars, etc., ESM sensors, electronic support measure sensors, much more advanced versions of what the Ukrainians had unveiled at one time, called the Kolchuga ESM system, basically. So to beat, broad, wide band, all aspect stealth vehicles, you will need a different kind of architecture, much more dense architecture with much more advanced systems, greater networking capability, and greater computing capability as well. So, having a country with by having the current setup where you are going to add another 40 or 42 petaflops next year, and that's just in the civilian on the civilian side, it's not going to work. You need something else now for very heavy duty stuff that's going to come, and you also need quantum sensing capabilities, especially for space based threats in the future. So Project Kusha, which is basically going to develop S400 and S400 plus equivalents, that has to be a sort of a core national project. Of course, it's being progressed by DRDO, and I am sure it's going to yield, because you see, you have that pedigree in missile development. So leverage that, leverage all the stuff, and perhaps you can show those images, Sriram, of the some of the images which were released on the sidelines of the event that celebrated the 1,000th blowdown at the hypersonic wind tunnel
Yeah,
in
let's
uh, in
let's
in
just
the
let's
APJ
just
Abdul
leave that for
Kalam.
now.
Leave that. Oh, we don't have that, is it?
No,
Okay. Anyway, that can
no,
be another
because it was
episode.
broadcast on DD.
Okay. Anyway, let's go with the last question for the day.
Okay. Um, let me see. Oh, by the way, a comment. Naval Pandey, loving the effort put in the production of the show. Slides, crisp sound, amazing. Thank you so much. It's been learning on the job kinds for us, but thank you so much for your support. What do you make? Okay, no support from the government. Yes, the government is trying to juggle many things. So lack of support, especially financial, is understandable, even if not condonable. How realistic will focusing on the AMCA alone with Rafales to bolster immediate fleet strength work against emerging neighborhood 5th gen threats?
Rafale can be an answer only if it comes as part of a package deal with the French, where there is a deep aerospace alliance with them on the engine front. Whoever, this whole MRFA should not be driven by ASR requirements, in my view. It should be driven by industrial requirements. Whoever will meet India's industrial requirements on the aerospace front should be the winner. And given what I have seen over the years, America definitely will not be that collaborator, because they're not even delivering F404s on time. So I mean, Lynn, Massachusetts is going to become a dirty term in the future in India. For those who came late, Lynn, Massachusetts is where the F404 plant is located, by the way, for final assembly. So anyway, so that's the Lynn in Massachusetts. So
Okay, one final
yeah.
question. Contribution from Rishabh also. Thank you, Rishabh, again. Very generous. Thank you so much. DDR did an interview on the UAV with ADE chief, not ADA, Mr. Dilip. What is the status of the
Why
Archer
Dilip?
NG? Is fabrication done, flying? And update on the Tapas. We will get you an update on all of these questions in about a week's time. Maybe not a week, I would say a couple of weeks, right? There's a conference that we will attend, and we will hopefully get answers for all of this, and we will come back and do an IH using and tell you what we learned. I hope you can wait for a couple of weeks. We are still waiting, and see, there's this thing where if a program succeeds or it's really struggling, news dries up. So we don't know which is which. So we'll just have to wait and find out what it is. And once we know what it is, then we'll definitely share it with you. I hope for a couple of weeks.
So on that note, we have to conclude this edition of Indigenization Appreciation Hour. I hope all of you got something out of it and understood the critical issues at stake, given recent developments. As always, there is no substitute to persistence and hard work and self-reliance. If you think that there are, then you might as well be my guest, really. So on that note, Jai Hind. See you the next time.
Thank you. Bye-bye.